argue that LLM coding tools run counter to the core principles, not only of the Clojure programming language itself, but also to the values the community espouses. Here with Easy Made Complex, please welcome longtime Clojure enthusiast, Josh Glover.
Hi, everyone. Can you hear me all right, I hope? Yeah. All right. So there have been a lot of fun talks here today. I decided to go a different way. I'm afraid jokes per slide will be a lot less than one of my usual talks. But whether or not we know this consciously, I imagine most of us are here today because of a set of values. And we all know the value of values, right? That was the one joke in the talk. So in this case, I'm talking about the values that led Rich Hickey to write Clojure in the first place, chief amongst which are simplicity, chief amongst which is simplicity, sorry. As a community, we talk about simplicity a lot. We honor it. We put it at the core of the way we think about problems and solve them. So a few years back, when mass market LLMs first burst onto the scene, I wasn't surprised to see Clojurists experimenting with them. After all, we're not very shy about messing with new technology. However, when LLM coding tools first started coming out, I was surprised to see Clojurists not only trying them out, but also picking them up and using them in earnest and talking about them a lot. I found this surprising because I feel that LLMs run counter to the core principles of Clojure, chief amongst which is simplicity. And I think we've forgotten an important lesson from Rich's talk. Things that are easy to use often result in great complexity. I'm going to tell you a story, but first, a few definitions. I think this is required by law in a Clojure talk. Sorry, second joke. I got to cut that out. I am almost 48 years old, and I've been programming for about 40 of those years. And when I first started programming, it was actually pretty easy for me. I had an Apple IIc near at hand. I had the operating manual for that Apple IIc with a chapter on AppleSoft Basic near at hand. I had a stack of Apple hobbyist magazines with programming listings you could type in yourself near at hand. So for me, programming was easy. I just picked up something that was near at hand and started typing. After some practice, I started understanding the constructs and concepts behind BASIC, and it became familiar to me. So I was able to modify the programs that I was typing in, just a little bit, but enough to make them do what I wanted to do and make them my own. After all, when you know how to use goto to jump to the end of a program, learning how to use it to make a loop is easy. And easy is wonderful when you're a child first falling in love with programming. But there comes a time to put aside childish things, because in easy, there be dragons, as Rich will explain. Let me quote directly from Simple Made Easy for a moment. I think that, collectively, we're infatuated with these two notions of easy. We are just so self-involved in these two aspects, it's hurting us tremendously. All we care about is, can I get this instantly and start running in 5 seconds? There's a third aspect of being easy that I don't think we talk enough about, which is being near to our capabilities. When we start talking about something being outside of our capabilities, it really starts trampling on our egos in a big way. So that was Rich from 15 years ago. But now we have a solution for that. Nothing is outside our capabilities as long as we're able to explain it in natural language to an LLM. It's easy, just generate the code. Of course, capabilities grow with experience. When we're first starting out, or first starting out with Clojure, very little is near our capabilities, so we lean heavily on the LLM. When we're experienced, our capabilities have grown to the point where we just delegate the boring implementation details to the LLM because we know which algorithms to use and we know which functions to write. This is great, right? It's so convenient to use a 10-word prompt to generate a 10-line function. But we're talking about code here, which is the construct, not the program, which is the artifact. As these 10-line functions grow, these implementation details that we don't have to concern ourselves with grow, what happens to our program? Does it meet our quality bar? Is it correct? Can we maintain it? Change it? This is important to think about. Now remember, Rich wasn't talking about LLMs in his original talk, but he might as well have been. In fact, for this next slide, let's just imagine that he was, and let the slide speak for itself. I might voice over it just to make it less boring. So the limits of humans, we can only hope to make reliable those things we can understand. We can only consider a few things at a time. Intertwined things must be considered together, and complexity undermines understanding. Now, do LLMs really change any of this? If we let agents consider things for us, we still need to consider the code they've generated. We still need to consider that which is intertwined, how that code interacts with other code, and we still need to understand the whole of the generated code in order to make the artifact reliable. But okay, let's say we successfully manage our swarm of agents to create a working artifact. Our users are happy, all good, right? Well, we know that users don't stay happy for long. They want a new feature to make them more productive, they discover a bug, so now you've got to make a change. And the primitive pre-LLM world, changes required analysis and decisions, like what will be impacted? Where do changes need to be made? In that world, in the old days, your ability to reason about your program is critical to changing it without fear. I'm assured by LLM-wielding programmers that this is no longer the case. Our agents can make changes for us. All we have to do is prompt, do this. No, not like that. Use a vector instead of a list. No, not like that. Use a transducer, otherwise this will take forever. And so on until we've got it working. Congratulations. Now we've become the guardrails that Rich warned us of. To paraphrase from his talk, we're like, I can make changes because I'm a great prompt engineer. Who does that? Who drives their car around banging against the guardrails saying, wow, I'm sure I've got these guardrails because otherwise I'd never make it to the show on time. There's another thing we should consider here. This, at the beginning, is where I think we are as an industry with our usage of LLM coding tools. And this is where I think we're headed, fast, at agentic speeds. And see, Rich even predicted vibe coding. So if we're just vibe coding at the weekend, we don't have to worry about this steep downward slope. But at our day jobs, when we're building things for the long term, we should be really worried about this. So here's where we are with LLMs. Many complicating constructs are succinctly described in natural language, which is familiar. And at the moment, LLM tools are very available. In fact, maybe even being shoved down our throats. And they're getting quite easy to use. But what really matters is the complexity they yield. And any such complexity is incidental. So Rich didn't put the definition of incidental on the slide, but he tells us it's Latin for your fault. Not my joke, that's Rich's. Here's the final definition of the talk. Complect. To complect means to interleave, entwine, or braid. And this is, of course, an archaic definition, so let's update it for the new world. LLMs complect the hell out of things. Perceptrons, layers, attention, backpropagation, projecting into higher dimensions, and then collapsing again, parameters, weights, multimodality. Just shove the entire internet in there. What could possibly go wrong? Rich gives us some general advice here on complecting. Don't do it. Best to avoid it in the first place. He then gives specific advice in the second half of this talk on what to do instead. Use Clojure. I'm going to try and get specific, though it will be hard. But first, just in case you think I'm twisting Rich's words to make an argument that he wouldn't agree with, let me share more of his words. This is from a gist he wrote about around Christmas last year. I'll just pull out one part of it here. Thanks, AI, for wasting vast quantities of developer time trying to coax some useful output from your BS generators. time which could instead be used communicating to interns and entry-level devs who, being actually intelligent themselves, could learn from what they are told and maintain what they make. He does have a few more things to thank AI about. You should read the gist. I'm not going to read these to you. Rich has quite a lot to say, it turns out. So what can we do instead? I think we should reject the idea that these LLM tools are here to stay and that we have to use them, so therefore we have to make them usable in a Clojure compatible way. No, Rich didn't find a way to use Java or C++ in a simple way. He created Clojure instead. And I think we should get back to the hard work of using Clojure to find simplicity for ourselves, of using our own brains to decomplect. Instead of letting discussions of LLMs suck up all the air in the room, and thanks for that not happening today, let's talk about simple and the joy of Clojure, not AI, which makes that easy. Thank you very much.